Hi friends, in this lecture we are going to see a topic on steady flow energy equation. Okay, let's see what is that. A steady flow process or steady flow energy equation. It's nothing but, first we'll move on to the example. Okay, for example, I have a box like this. Okay, I have a box like this, and this dot line represents my system. Okay, this is my system. Under system is nothing but the area which is my interest, or the area under concentration, and we are going to calculate everything related to this one only. Okay, and suppose, and this is my inlet, it's nothing by inlet, this is my outlet. Okay, and I am supplying, or I am injecting some sort of fluid. Okay, some fluid is getting in. So the fluid, I know some properties of the fluid. Okay, what are all the properties is my pressure P1, and I am sending it at specific volume, certain specific volume V1, then the area A1, comma, and the internal energy, I know my internal energy U1, and my velocity is V1. Don't confuse, this is my specific volume, and I will write like this Vs. Okay, specific volume, this is my velocity. Okay, and the distance between this ground to this, or you can say it as a datum height. Okay, this is nothing but datum height. I will write it as Z1. Okay, and now coming to the outlet, after certain process occurring here, my outlet fluid is having some sort of pressure P2, volume V2, and my specific volume. Okay, specific volume is nothing but mass per volume, right? Volume per mass, yeah. And velocity V1, and internal energy U2. Sorry, this is V2 and this is U2, and my datum height is going to be Z2. Fine. Now with this property we can relate, according to the first law of thermodynamics, energy which is getting in is equal to energy which is getting out. Okay, energy neither be created nor be destroyed, but can only transfer from one form to another. Okay, from that one I am saying whatever the energy which is getting in from this inlet is equal to whatever the energy which is coming out from this outlet. Fine. So what I can say is E1 is equal to my internal energy U1 plus my flow or displacement energy. Okay, then my kinetic energy and my potential energy, and heat which is supplied inside. Okay, or you can say it as Q. Fine. Now internal energy is U1 plus what is my flow or displacement, which is nothing but pressure P1 and V1. How it has come? Flow is nothing but uh, force into area into the amount which is distance which is traveled. Okay, x. What is force? Is nothing but pressure by area. Am I right? Pressure is nothing but force per area. So my force is pressure into area. Okay, I can write it as pressure into area into x. Okay, I will tell you what is flow energy or displacement, okay, which is nothing but force into distance moved or displacement. Okay, what is my force? Force is nothing but pressure into area, right? Pressure into area into displacement, I can say it as L. So what is area into length is nothing but my volume, pressure into volume, that is my flow. Fine, so I can write it as flow or displacement energy as P1 V1. Fine, what is my kinetic energy? Is nothing but half mv square. Everything is calculated on specific volumes, okay, so I am not going to write my mass here, okay. Then my potential energy is nothing but acceleration due to gravity into z1, that is my height, and after that heat which is supplied. I will take that one as QH or Q1, whatever. And now I need to calculate my energy which is going out. It's nothing but the same internal energy of outlet and flow energy P2 V2 plus potential energy GZ2 plus work which is done, okay, work which is done. I will write it as work output W0. Fine, now according to steady flow energy equation, we can write my E1 which is equal to E2, that is nothing but U1 plus P1 V1 plus ZZ1 plus, I'm sorry, I left my half V2 square here, okay, this is my half V1 square plus QH which is equal to U2 plus P2 V2 plus ZZ2 plus W0 plus half V2 square. So as we discussed in the previous lecture, my U2 P2 V2 is nothing but H, that is nothing but enthalpy H1, okay. This is my ZZ1 as it is, just put everything as it is, which is equal to H2 plus ZZ2 plus W0 plus half V2 square. Fine, that's it. This is my steady flow energy equation. Case 1. In case my potential energy is 0, that is my Z1 which is equal to Z2, as we know we can cancel these two terms, okay, the remaining is going to be my answer. And in case my potential kinetic energy is 0, then I will cancel P1 which is equal to V2, then I will cancel this one and this one, right? This is what we call it as steady flow energy equation.